So what is real-time virtual reality? Well, it's a combination of components. It's an Oculus Rift DK2, an Xbox Kinect with Xbox One, it's a PC, and it's a lead-acid battery. But more importantly than that, it's a system that brings those components together, or actually very few of those components together, and allows a computer to scan the environment in real time and display a 3D image back to us. Now, that doesn't even need to be in a virtual reality headset. We've been able to do this for a long time. But the concept of having a first-person viewing angle with that information then being relayed directly into a VR headset opens up a world of possibilities. In its most basic form, the Xbox One Kinect uses its infrared depth detection sensors, which fires a hell of a lot of infrared light out in front of itself in a dot matrix, waits for that light to bounce back off any object surrounding it, and the time it takes for those lights to hit an object and bounce that light back into a sensor tells the Xbox One Kinect how far away that object is. Now, that information is then sent through the computer, put together as a wireframe mesh, skinned, textured, and sent back to the Oculus Rift DK2, kind of like a black and white image. Imagine just having your vision right now in full colour and turning it grayscale. That is the basic system of how we start with real-time virtual reality. Now, that might not seem that exciting, and it's not. Grayscale images, I mean, dogs see in grayscale, but they have an amazing sense of smell. Except that's not quite how the system works. We already can relay a camera in full colour in real time to a screen. Every time you get out your smartphone and you take an image with it, you're not seeing that through a DSLR that's got mirrors there and you're looking through a direct viewfinder. You're actually looking through a sensor, through a screen, and you're seeing everything as it happens. Nothing too impressive. I mean, to do it in black and white is certainly not impressive. So how does this differ from a camera with a big LCD screen on the back of it? Well, depth data isn't quite the same as light data. Light data is a true representation of everything that a sensor can see around it, and that's a flat image. Whereas depth data is a true representation of everything that a depth sensor can see around it, and that's a 3D, I wouldn't refer to it as an image, more as a model happening on the fly in real time. Now, that means that you can move the perspective of that camera around that image and look from different angles, but that's probably a little bit too zany out there scenario. What we're more aiming for is to view everything in first person and then relay that in first person back to the VR headset. We already use some of this technology. Just think of self-driving cars. I mean, Tesla is planning by the end of 2020, potentially, that all cars that they produce will be completely self-driving. We've had portrait mode photos for the last number of years on smartphones, and that is essentially the same piece of technology that we're using inside real-time virtual reality. The camera in the smartphone is sensing the depth of the objects within the frame and then applying blur to those in the background and making sure that the ones at the front are nice and sharp and in focus. And that is a machine added blur. It's not a naturally occurring lens effect. So it's using exactly the same depth sensing technology. Now, with that data, we can start to manipulate what goes on in the real world. Whether that's adding objects in, changing what an object might be, or even skinning every single component of that 3D scenario to be a completely different object. One of my favourites is we're in London, and around the time I first came across this idea, Assassin's Creed was releasing a version of their game set in London. And I was like, well, this is perfect. Imagine walking through the streets of London, the real streets. Let's say we're walking past Parliament, and Parliament today still looks very similar to how it would have done back a few hundred years ago. But imagine if you could be walking along the street past Parliament. People are dressed today in modern suits, modern tracksuits, trainers, woolly jumpers, baseball caps, all kinds of 21st century clothing. But you're walking past people dressed in full Victorian garb. You're walking down the street and there's horse and carriages, women in petticoats, there's men in full tailored suits, there's chimney sweeps walking past covered in dirt. All of the streets are covered in cobbles, there's smog filling the air. How incredible an environment would that be to exist in the real world still? That is the potential of what real-time virtual reality can do. More abstractly than that, imagine going to your local park, going into the forest, going into the woods. You're surrounded by trees, yet all of a sudden there's dinosaurs, cavemen, there's woolly mammoths, there's all of these things that have existed throughout history there for you to interact with within your real world. That is what we can achieve. And it's a long way from now, but it's where this project is heading to.